Boo! It's Halloween, my favorite night of the year. My little blue bucket that I carry around usually has a normal variety of candy. Circus peanuts are my favorite though. I just seem to love them so much. I usually only get them 33% of the time though.
I absolutely love trick-or-treating. I go out with a group of my friends and we collect all of our favorite candy. Sometimes I get other candy, and sometimes I get my absolute favorite, circus peanuts. When I went trick-or-treating this year, I scored 5 circus peanuts in a row.
Isn't that exciting?
Yes, I ate them all right away.
I bet your mama loved that.
Yep, I was on a sugar high for at least a week.
Wow, that seems really unusual that you've been getting more circus peanuts, like 5 in a row?
Yep, I've been getting more circus peanuts recently than the previous years.
Do you think your 5 in a row experience is evidence that circus peanuts are becoming more popular than the usual 33% that you get?
I don't know. Let's run a simulation.
How would you run that? What even is a simulation?
A simulation is an imitation of chance behavior. It's usually carried out with random numbers. There are 4 total steps to the simulation process. The first is to state the question. The second is to plan the simulation. The third is to do the simulation. And the fourth is to conclude. These 4 steps will lead you to a successful simulation. Let's take an in-depth look at each of the 4 steps.
Okay, let's do it.
The first step in this process is to state the question. For this simulation, we will ask the question if receiving 5 circus peanuts in a row, like I did, is caused by chance behavior or is it caused by an increase in popularity? We will also assume that each of the trials are independent of each other.
What does it exactly mean that the events are independent of each other?
This means that the result of one trial does not affect the results of another trial. In this process, we will also assume that we have a 33% chance of getting circus peanuts than any other candy.
The next step is to plan the process. In planning the process, we will assign digits. In this simulation, we will be using a dice. We will assign numbers 1 and 2 will represent circus peanuts, which is a 33% chance, and numbers 3 through 6 will represent other candies. Each trial will consist of 5 dice rolls, and we will run 20 trials to record how many times we get 5 circus peanuts in a row to determine if it is by random chance or increased popularity.
So, do you always have to use a dice to assign the random numbers?
No, you can always, for simulations, you can use the random digits table or any other random chance device. So, how do we exactly record our results?
In this process, we're going to record our results by making a table and tallying each trial that we get 5 circus peanuts in a row and each trial that we do not get 5 circus peanuts in a row. With these 20 trials, we had 5 trials with 5 circus peanuts in a row, and the remaining 15 trials, we did not get 5 circus peanuts in a row.
The last step is to conclude our information, after doing, of course. So we had 5 out of 20 that were 5 in a row. That's 25%. By random chance, we should have had 0.412% of 5 in a row peanuts.
Whoa, that's a big difference.
Yeah, it's much larger. So therefore, we conclude that there is an increase in popularity of circus peanuts, and it wasn't just random chance.
I totally agree. Because of this, we can conclude that circus peanuts are definitely increasing in popularity.
Happy Halloween!